So for question 21, we're asked to find the pH of a solution after adding 0.02 moles of sodium hydroxide to 250 milliliters of a buffer. And that buffer contains 0.4 molar HF and 0.8 molar potassium fluoride. And they tell us that the Ka for HF is 7.2 times 10 to the minus 4. So again, Henderson-Hasselbalch equation, right? We've got our weak acid, its conjugate base, but we have to do one thing before we do that. And to kind of maybe help visualize that, I would draw it as something like this. Right, here's my 0.8 molar potassium fluoride and my 0.4 molar HF. To that, I'm going to add the sodium hydroxide. Sodium hydroxide is a strong base. But I also need to know, right, we know moles of sodium hydroxide. I need to find the molarity of that so that I can directly just subtract or add depending on where it reacts. So I've got 0.02 moles of sodium hydroxide, and I dissolve that, I mix that in 0.25 liters of solution, right? We're looking for molarity, moles per liter. Of our sodium hydroxide. So I get a 0.08 molar NaOH. NaOH is a strong base. So essentially we're adding 0.08 molar of a strong base to that solution. So where's the strong base going to react? That's the question we have to ask. What concentrations are going to change here? All right, our strong base is going to react with my weak acid. So I want to subtract 0.08 here because it's going to neutralize 0.08 molar of my weak acid. So this concentration goes down. The product of that reaction, right, when HF reacts with hydroxide, the product of that reaction is going to be water and more fluoride, more of the conjugate base. So this concentration is going to go up. So we're going to add 0.08 molar there. So after and at the end of that, all of the sodium hydroxide reacts. It's all consumed. So at the end of that, I didn't quite give myself enough space, but we're going to have 0.88 molar potassium fluoride, or essentially just fluoride that we're worried about there. And we're going to have 0.32 molar HF. Now we can use the Henderson-Hasselbalch equation, right? pH equals the pKa plus the log of the concentration of my base over the concentration of my acid. So the pH of this solution is, the pKa is the negative log of 7.2 times 10 to the minus 4 plus the log of my base. My base is potassium fluoride, 0.88, and my acid is the HF, 0.32. Now I can find the pH of that solution. Right, so negative log of 7.2 times 10 to the minus 4. And I'm going to add in the log of 0.88 divided by 0.32. And I get a pH of something like 3.58 for that. So any questions on 21?